Good morning, Mr. Walcott here. The goal today is to talk about slope-intercept. These functions, tables, and graphs are all ways to show proportional relationships. And our goal is to help everybody finish up 5.04, our mid-module check on slope-intercept by this Friday. We've talked a lot in class about real-world relationships that can show up as linear functions that have a slope, that have a slope and an intercept, right? Anytime you say per, you can probably have a linear relationship. So wheels per car, giraffes per zoo, penguins per iceberg, miles per hour. Whatever it is that you want to represent in a linear relationship, you can do that on a graph, you can do that on a table, and you can do that with a function, which you see here in the center of your screen. So before we get into a couple of the problems, let's talk specifics. We're going to need a new color. Here we go. Anytime we have a linear function, we're going to talk about two variables, x and y. Here they are in the function, and here they are on the table, the x-axis and the y-axis. Okay? Always a relationship between two variables to create a function. When we talk about the slope of the function, we're always talking about a multiple of x. Slope goes right here next to the x. It's usually what we're multiplying x by. It can also be something we divide x by, but it's always right there next to the x variable. That's where slope belongs. And slope is the rise of the line divided by the run of the line. If you can remember rise over run, you're going to be in really good shape on these assignments. Let's make sure we understand what rise over run means. Here's the graph of our function, and I'm going to look specifically to count rise and run from a place where our line crosses the grid at an intersection, right? I don't want to try to count from here. That's not at an intersection on the coordinate plane. That would be very difficult to count. I want to count from right here, and I'm going to count grid squares. I'm going to count 1, 2 up, and 1 over. So a rise of 2, a run of 1. I'll put that in slope form. That's rise over run. And of course, when we talk about whole numbers, we don't necessarily need to write the bottom 1. Okay? So we can express this as a slope of 2. Now, when we back up and go back to our function, we're going to see that slope of 2. It's right here. Okay? It's already in the function. We're multiplying x by 2 every time. That 2 literally says go up 2 for every 1 that you go over. That's what makes the line have the slope that it has. Okay? So slope-intercept formula needs a rise over a run. Okay? Anything that we put on the coordinate plane is going to cross the y-axis at some point, unless we put limits on it or we're expressing an inequality. Okay? This is not an inequality. This is an equation. It's got an equal sign. Here's our other equal sign. So we know it's going to intercept. It's going to cross paths with the y-axis at some point. We want to know where that is because that's an important part of our equation, our function as well. So again, let's zoom right in here. Let's see if we can figure this out. Here's our x-axis down here. Here's our y-axis. They cross at the origin when x is 0 and y is 0. But what we're really interested in is where does the line cross the y-axis? Where does our function intercept the y-axis? It's not here at the origin, okay? But it is just like saying when x is 0, what will y be? So in this case, when x is 0, y is right here. 1, 2, 3 up. So when x is 0, y is 3. That's the y-intercept. We'll find it right here on the graph. And there in the end of our function is a +3, which says the same thing. When x is 0, y is +3. And when we look at our table, we'll find the same thing. When x is 0, y is +3. Okay? So we need these two concepts to be able to keep track of our function, to understand and represent it. And all three of these things, the table, the function, and the graph, represent the same mathematical concept. One is geometric, one is algebraic, and one is arithmetic, right? We've got three sides, three ways to represent the same mathematical truth. So we're going to keep all this in mind, the intercept and the slope, as we go forward and take a look at our problems.